Welcome to this DEEPLIZARD series where we deliver bite-sized, practical, and intuitive explanations for the most common terms and concepts in the field of deep learning. I'm Mandy, and the topic of this episode is nodes, or the neurons present in artificial neural networks. An artificial neural network is made up of multiple processing units called nodes or neurons. These nodes are organized into layers, and the layers are connected to each other by weights in the network. The number of nodes present in any given layer of a network partly depends on where in the network the layer resides. It also partly depends on the data that will eventually be processed by the nodes in a given layer, and also partly depends on the design choice for a given layer by the network architect. For the input layer, the number of nodes is directly determined by the number of input features of a single sample that will be passed as input to the network. In this illustration, our neural network has an input layer with 2 nodes. So this indicates that our input data, that a single sample from our input data would have 2 input features. For example, we could have a data set where each sample represents an individual person, and within each sample we have 2 features like the height and weight of the person. So this height and weight is what would be passed as input to the network and would therefore represent our 2 input features, our 2 nodes in the input layer. If we're using the network for classification tasks, then in our output layer, the number of nodes has to be equal to the number of output classes. So again, with this illustration, we have 2 nodes in our output layer. So that means that we have 2 output classes for which our network will be supplying predictions for. So we can see that the number of nodes both for our input layer and output layer are bounded by the type of data as well as the number of output classes that we have. With the hidden layers, on the other hand, we have more freedom in choosing the number of nodes that we include within any given hidden layers. So we could arbitrarily choose the number of nodes, or we could choose them empirically based on experience from what we have seen in prior networks that have worked well for similar tasks to ours or similar data to ours. As we briefly mentioned earlier, a node in any given layer is actually just a processing unit that will process data eventually once it is passed to it. We can zoom in on the function of a single node within a hidden layer to see generally what it's doing once data is received by it. So this is representative of a single node within any given hidden layer, and it will receive data as input from the previous layer, which is connected to it via these weights here. So after the node receives the data, it will process the data in some way, and then it will send the output of this node, this processed data, as output from this node onto the next layer via the connected weights here. So each node will have an output value resulting from some operation that occurs between the data that is being passed to this node from the previous layer, as well as the weights that are connecting the data to this node. And then this output value will be passed as input onto the next layer. The specific operation that is occurring on the data that is passed to a given node will depend on the type of layer that the given node is part of. In later lessons, we'll elaborate more on the types of operations that are occurring within these nodes.